Hi guys, welcome back. If you're new here, my name is Michelle. I am an SAT math tutor, so if you're studying for your SAT, prepping to do a retake, make sure you hit the subscribe button down below to get a notification each time I release a new video. Also gonna link my TikTok down below. I do an SAT problem of the day, so hit that description bar and follow me there as well. Okay, let's jump right into it. Today we're gonna be doing the 3 math hacks you need to know before you sit for your SAT exam. Math hack number 1, plug in your answer choices. I have so many students that are reluctant to do this, but I'm here to break your myth. Yes, plugging in your answer choices is actually a smart way of solving certain SAT problems. And a lot of the times, actually plugging in your answer choices makes you solve the problem far more efficiently than if you actually go the algebraic way. So the question I always get is, Michelle, when can I plug in answer choices? When do I know that's a good method to use? I really have 2 answers. Answer number 1 is if you're looking at a problem and you don't see the algebraic way to solve it, you don't actually understand exactly what's being tested, you haven't seen a problem like this before, that's always a great point where you should say, okay, let me look at the answer choices, let me see if I actually could plug in. The other time is when your answer choices are all numbers. That's always a great sign that you can actually back solve and use those answer choices to see which one actually is the solution. So let's do 2 examples of when I would use the plug-in method on the SAT from the real SAT practice exams. So question number 1 is, if x and y are positive integers, okay, what are all the solutions of x and y of the equation 3x plus 2y is equal to 11? So in this case, actually plugging in is one of your only options, right? So let's plug in efficiently. The first thing I notice is that 1 and 4, that x and y appears the most in all of my answer choices. So I'm going to test that one first because maybe I can get an easy elimination. So let's say x is 1, y is 4, so I get 3 times 1 plus 2 times 4, so that's 3 plus 8, which is 11. Does that work? Yes. So I know that B is out right away and E is out right away. Okay, let's check, why don't we check the 3-1 answer choice D, just because I see 3-1 appeared twice and usually that's how the SAT wants to get you, right? So I'm gonna try x is equal to 3, y is equal to 1. Okay, I get 3 times 3 plus 2 times 1. That gives me 9 plus 2, which is also 11. So I know 3 and 1 work, and my answer choice has to be D. Okay, so far easier. What was the method I used? I first noticed what is the answer choice that appears the most frequently, and I worked from there to find the correct solution. Okay, let's try a different one now where maybe the plug-in method doesn't seem the most natural way to solve it, but it is a great method to use in this particular case. So we're being given a systems of equation, and we're being asked to find y plus z. So we have the 2 equations. First thing I notice is I can rewrite, I kind of want to get my y plus z by itself. So I'm going to rewrite that first equation just to get that y plus z by itself. So I get 3x plus 2. I'm going to factor out that 2. I'm going to get y plus z in the parentheses is equal to 19. And then on the bottom again, I just have 3x plus y plus z is equal to 14. I'm going to put a little parentheses around that. And now what I want you guys to do is just plug in your answer choices. It's always a great method to start with answer choice C when you're plugging in, simply because it might be helpful to go a little bit under or a little bit over when you're plugging in. So let's plug in 0. When I get 0, I get 3x is equal to 19 and 3x is equal to 14. That 0 kind of eliminates everything after the 3x, so I know that can't be it, right? Let's go to D now. 3x plus, then I'll get 2 times 4, which is an 8. So I get 3x plus 8 on the top is equal to 19. If I subtract 8 from both sides, I get 3x is equal to 11 on the top. What about on the bottom? I get 3x plus 4 is equal to 14. 3x is equal to, subtract 4 on both sides, 10. So 3x is equal to 11 and 3x is equal to 10. That's not the same, so I'm going to cross out D. Now I'm going to try E. So I get 3x plus 2 times 5 is equal to 19. So I get 3x plus 10 is equal to 19. 3x is equal to 9. Obviously, x is equal to 3. But let's see if I get the same answer for that second equation. So now I get 3x plus, again, 5 is equal to 14. 3x subtracting 5 from both sides. I get 3x is equal to 9, x is equal to 3 as well. Boom, that's my answer. So I've only had to test 3 numbers here. Again, if you forget the algebraic way of doing this, this is a great solution. If you're stumped and you're like, how do I get this question really quickly? Don't forget that plugging in, you don't have to have the most mathy solution, right? Plugging in works. And so use it to your advantage on the exam, because I'm going to tell you, a lot of the times, especially those folks who are already scoring high on their math section, they're kind of obsessive about finding the most efficient mathematical solution. And I'm here to tell you guys, sometimes the most efficient solution is plugging in the answer choices. And the test is going to play with you, especially if you're scoring in that higher range. You know, they're going to give you very convoluted algebraic solutions versus just plugging in, which is going to end up being much faster. So anytime you have a number in your solutions, anytime you forget the algebraic solution, or when you're looking at the algebra, you think it's going to be really messy, try plugging in. It will work most of the time. It will be one of the most efficient strategies. So don't underestimate plugging in your answer choices. Math hack number 2 is actually choosing smart numbers. So you can actually, for a lot of the SAT questions, choose your own numbers to fill in, and all of a sudden a very convoluted problem becomes far easier to understand because you've plugged in numbers, you've gotten rid of the variables. So when is it a good idea to actually plug in numbers? Well, anytime you have the same variables being used in the answer choices and in the problem, great clue that you can be plugging in your own numbers. Also, if you're ever given ratios without an actual total, percentages without an actual total, it's always a great place to start. Plugging in will actually help you visualize. So in these problems, unlike math hack number 1, we're actually going to be choosing our own numbers. So let's start with the first one. Here we have an expression 5x minus 2 over x plus 3, and we're being asked which of these following is equivalent. And I see some of my answer choices have variables, some of them just have numbers. So what I'm going to do is I'm going to plug in x. I'm going to choose a number for x. Let's choose x is equal to 1. So what do? I'm going to evaluate this expression, and then I'm going to see which of the answer choices will give me the same answer. So when I plug in 1 here, I get 5 times 1 minus 2 over 1 plus 3. So I get 5 minus 2 over 4, and I get 3/4. So I'm looking for the answer choice that actually gives me 3/4. Well, the first one gives me what? 5 minus 2 is 3 over 3, which is 1. A is already out. Look, we've already crossed one out. B, 5 minus 2/3. Well, I know that's 4 and 1/3, right? Is that 3/4? No. Be very careful. Look how sneaky they are on that one. All the numbers that you're looking for are kind of there, right? The 3 and the 4, but they're not the correct way. So that one's out. I'm looking for 3/4. I'm not looking for 4 and something, right? Okay, now we're going to be plugging in 1 again for these C and D. So 5 minus 2, 1 plus 3 is 4. So 5 minus 2/4 is the same as 5 minus a half, which is 4.5, which is not 3/4. That one's out. And then D, 5 minus 17 over 1 plus 3 is 4. Okay, this is the only one where I have to do a little bit more math. I'm going to multiply my 5 by 4 so I get a common denominator. I get 20 over 4 minus 17 over 4, and there we go, bingo, we get our answer. So even though I started with A and my answer choice is D in this case, I kind of went through these problems really quickly because as soon as I plugged in 1, I was able to visualize what I was looking for, and it became far easier. So again, don't underestimate choosing your own numbers. Fill in your own numbers. Make sense of the math in a different way. Don't always think that algebra will be the fastest way. It's not. So anytime you have a lot of variables or variables appearing in your solutions, I always recommend plug something in for the variable. Let's do an example when you have an unspecified value. And what I mean by that is there's some number that's missing that would make the problem so much easier to visualize. So this is a perfect example. Mary spilled 2/5 of her peanuts and Jessica ate 1/3 of what was left. Okay, Jessica then gave peanuts to Max and Sam, who ate half of what remained. What fractional part of Mary's peanuts did Sam eat? So there's a lot of fractions and no concrete number for me to attach myself to. I can't visualize this. So anytime you have a problem like this, you have to think about a smart number. plug in a smart number for the total. All of a sudden when you do that, the math becomes so simple. So what's a good number to plug in here? I always say when you have fractions, look at the two denominators and multiply them together, because that'll make it a lot easier to take the fraction part of. So in this case, the denominators are 5 and 3, so I'm going to say my total is 15. So if my total is 15, she has 15 peanuts. She spills 2/5 of them. So how much does she spill? She spills 2/5 times 15. So that becomes 6. So she spilled 6. So how many does she have left? She has 15 minus 6, which gives me 9 left. Okay. Then Jessica ate 1/3 of that. She ate 1/3 of what was left. So Jessica ate 1/3 of 9, which is 1/3 times 9, which is just 3. So Jessica ate 3, which is how many are left then? So if Jessica ate 3, there's 6 left now. Okay. And then Max and Sam, so Jessica gave the rest to Max and Sam, who ate half of what remained. So that means Max and Sam ate 3, right? What fractional? So that's what Sam ate, right? What fractional part of Mary's peanuts did Sam eat? So Sam ate 3 peanuts, and what was the total, right? 15. So 3 over 15 simplifies to 1/5, and my answer choice is C. Do you see how much easier it is once we plug in a total? It's so much easier to actually take the parts, right? Otherwise you're dealing with like a variable. If 2/5 of X, 1/5, it's so much harder to visualize if you're trying to do this algebraically. So plug in. If you're given a percentage without a total, if you're being given a ratio, or you're taking a fractional part, like in this example, always plug in a total, and always a safe total is, I mean, if you're dealing with percents, 100 is a nice number to deal with. And when you're dealing with fractions, I always say, look at those denominators. A lot of the times, if you multiply the denominators, you'll find a nice number to work with. Okay, last little hack here. Hack number 3. Underline what you're solving for. What you're going to notice on this exam is they're going to kill you if you end up solving everything correctly, but there's just like a slight spin of what they're asking you for at the very end. So look at these questions I pulled here. A lot of the times what you're going to find is some algebraic expression, they're asking you to solve for x, solve for x, solve for x. And then you'll get a few exceptions where they're asking you to solve for 8x, or they're asking you to solve for y. And you've done all this work to find x, and then you end up circling the value of x instead of 8x, or the value of y. So my recommendation, and I tell this to all of my students, always, always underline. Get in the habit from the very start when you're studying and practicing. Underline what you're looking for. And then once you solve and you do all of the math, go back to where you circled. What am I looking for? Oh yeah, I'm looking for y. I'm not looking for x. Or I'm not looking for x, I'm looking for 8x, whatever the case is. The last point I want to make is a lot of the times when you're being given something like an equation, and then you're being asked to evaluate a weird expression, that's your clue. So a lot of times what they're actually asking you as a question is your clue. It's like, what do they really want? So they're giving me in this example 14, an equation, and then something with exponents. And I'm like, okay, well, that exponent one doesn't look anything like the equation that I'm being given. But there's a reason they're giving me the equation. I have to use that in a simple way. So I always say with exponents, the best thing to do is always try to simplify to the same base. So in this case, I have 8 to the x, 2 to the y. I know I can rewrite 8 as 2 to the third, because 2 times 2 times 2 gives me 8. So 2 to the third to the x over 2 to the y. Okay, so what can I do? Am I getting closer to finding 3x minus y? Maybe I now see a 3 and an x and a y. Boom, right? All of a sudden it appears on my paper. All I did was somehow take what they're asking me to look for and make sure I rewrite it with the same base. That's your clue for exponents. Rewrite with the same base. So now I say, okay, I have 2 exponents. I have 2 to the, anytime you have an exponent to an exponent, you just multiply. So 3 times x. So I have 2 to the 3x over 2 to the y. Fabulous. I have the same base. I'm dividing my exponents. When you divide exponents with the same base, all we're doing is subtracting those exponents. If any of this sounds confusing with exponents, I have a video on exponents that kind of goes through all of these rules. So take a quick peek at that video. Okay, so we have 2 to the 3x minus y. Boom, guys, look at that. They're giving me what 3x minus y is. So all I'm trying to find is 2 to the 12th power, which is a. So, big hack for the last one. Always underline what you're looking for. If you're being given something and then you're asked to find something else that doesn't look very similar, try to work with what you're looking for to make it look like what you're being given. So in this case, we were being given 8 to the x, 2 to the y, which looked like it had nothing to do with that 3x minus y. But I was able to do something with that 8 to the x over 2 to the y in order to get that 3x minus y. Okay, those are my 3 math hacks. Of course, there's so many more things that I want to share with you guys. So make sure you hit subscribe, and I'll see you next time. Bye, guys.